So guys, what we have here is a question which was asked in the 2013 December NET exam. The question is that the Hamiltonian of a relativistic particle of rest mass m and momentum p is given by h equal to root of p square plus m square plus v of x. So there is potential, and then there is kinetic part which has the velocity component over here and the position component over here as the potential part. So that's the Hamiltonian, yes. And oh, I forgot to write down the options. So yeah, now we have our options here. We have different options, and we need to find out the corresponding Lagrangian. So we have done enough problems to see and understand how Lagrangian and Hamiltonian are related, and all that theoretical background we have explained in different problems. So I'm not going to do that now. What I'm going to write down first is I'm going to say that Lagrangian is considered as equivalent to energy, and Hamiltonian is also considered equivalent to energy, except with the difference that Hamiltonian can be represented as t plus v in some basic form, and Lagrangian can be represented as t minus v in some basic form. Okay, so that's one thing. And we can use Euler-Lagrange equation to minimize the action and find out the exact equations of motion. That's one thing. That's not what we are here to do. So basically we are given the Hamiltonian, so we need to find the Lagrangian. So transformation from Lagrangian to Hamiltonian, we have done this earlier, but I'm going to specify that the equation can be written as sigma I qi dot into pi minus Lagrangian will be the Hamiltonian, and vice versa Lagrangian will be sigma qi dot pi of our I minus Hamiltonian. So this is the relationship that which I can specify. Now what we can do is that we can actually find the Lagrangian using the Hamiltonian. Okay, given Hamiltonian. So basically that's what we are going to do. So we need to find out q dot. Q dot is the position coordinate, differential of the position coordinate with respect to time, or in other words here it's a position coordinate, so it's a velocity. So we can find q dot by using the Hamilton's equations. Okay, Hamilton-Jacobi equations, and we can use that. We can say that q dot is equal to dou h by dou p, and similarly p dot can be also be found out using this equation, which is q dot, which we don't actually use here. Okay, these are the two relationships there. Now we can go straight forward and find out q dot and substitute the value here, or see which value suits the equation and find out the Lagrangian. So we can find out q dot by taking the derivative with respect to p of the Hamiltonian here. So it will be root of something is 1 by 2 root of that, right? So it's 1 by 2 root of, that's the derivative right there, m square, times the derivative of what's inside is 2p. So I've done a small differential here, it's an easy one, plus plus nothing, so plus 0. So next thing that we have found out the relationship of q dot here. So we can simplify that, and you get root of p square plus m square, and you can take a p square outside, and you get p by p into square root of 1 plus m square by p square, and you can say that it's equal to, so this will be equal to 1 by root of 1 plus m square by p square. So we found out q dot and p connecting equation here, and we can find out p from here. Okay, we can find out the momentum, generalized momentum here. We can use that relationship, we can cross multiply them, and you get q dot into root of 1 plus m square by p square is equal to 1, right? I just cross multiplied these two equations, and what you will effectively get is you can take the squares, and you get q dot square times 1 plus m square by p square is equal to 1, right? So that's this is only simplification part here. So you can say that q dot square plus m square q dot square by p square is equal to 1. So basically you can take it on both sides and you get q dot square is taken outside. It's 1 plus 1 minus this was gone. Okay, I'm going to do all the steps, that's why. Okay, q dot square is equal to 1 minus m square q dot square by p square. So this will be what? Okay, now we can multiply them both. I should have done this easier way, but it's all right. We can get this right. P square minus m square. I just cross multiplied it all together, and now what we can do is that we can take p square out and get this on to this side, and you get p square into q dot square minus 1, which is equal to m square minus m square q dot square minus m square q dot square. There is a minus sign there. So this will looks like p square is equal to m square minus m square q dot square by q dot square minus 1. So p will be equal to m square q dot square or x dot square. Okay, q is x, right? So it will be x dot square 1 minus x dot square. So that's p right there. So I just simplified that. We found out p. Now what we need to do is we can substitute the value of p into the equation, this equation, and find out. So Lagrangian, we can find out Lagrangian. So there is only sigma qi pi is just qi dot pi. Qi dot pi is just qi dot pi, which is qi dot q dot p. Okay, q dot b. It will be x dot p. It will be x dot times m square x dot square by 1 minus x dot square. So I just replaced the minus sign with and shifted the 1 minus x dot square, and this is what you get. And this is Lagrangian minus Hamiltonian, which is root of p will be m square x dot square by 1 minus x dot square. 1 minus x dot square, which is p in the Hamiltonian right there. In the where is the Hamiltonian? Yes, there is a Hamiltonian. That's p right there, or you can say p square. So this is p square, right? So this is p square. So p is square root of this. So square root of this, square root of that. So p square is just this times what? So I'm making a lot of mistakes here. I'm sorry about this, but p square is that minus p square plus m square plus v of x. So that's what it is. So x dot square and square root of x dot square, which will give you x dot square m by root of 1 minus x dot square is just root of 1 minus x dot square minus what? M square x dot square. So you can cross multiply that, and you can cross multiply that. I'm going to do the rest of it here on this side. The rest of this part, you get the square root of m square x dot square plus m square minus m square x dot square. I just cross multiplied it, this term, on either sides, and by 1 minus x dot square, of course, plus v of x. So that will be okay. We are running out of space, but it's all right. You can cancel them both, right? They are both the same. So you get what you get. Lagrangian is equal to x dot square m or mx dot square plus square root of, okay, the common denominator here, 1 minus root of 1 minus x dot square. So it's 1 minus x dot square minus only m square. So m square is root of m square is m. So it's m plus v of x, of course. So this is m into 1 minus x dot square. So I'm going to take an extra space here. extra column here, and you can take out x dot square or m outside, and you get 1 plus x dot square by root of 1 minus x dot square. So there is a minus, there was a minus sign, then this is also a minus sign. I missed a minus sign. This is a minus sign, right? So there will be a minus sign here, and there will be a minus sign here, and there will be a minus sign here as well. Okay, so here is v of x right there. I just take out 1 minus x dot square. So root of 1 minus x dot square and 1 minus x dot square is just m times root of 1 minus x dot square, right? So it's just m times root of 1 minus x dot square minus v of x right there. So that's the answer right there. So the answer, the option which is the right one is m root of 1 minus x dot square minus v of x, which is option A, as you can see clearly, right? Yes, option A. So that was a very easier question, because it's easier to solve, right? It's easier to solve. You just have to do the mathematics. You don't have to do anything other than that. It was simple. So I hope you guys understood it very well. For more videos, you get to this link, t.me CSIR Physics.